Okay guys, so for our first lesson today, we're going to be talking about direct variation, which just means that when you have two different things, they have a direct relationship with each other. When one increases, the other one increases. When one decreases, the other one decreases as well. So the way we represent this mathematically with an equation is the equation y equals a times x, which is right there. And what we say about that is that there is a direct variation between x and y. Now, in that equation, if you notice, we have a little letter in here called a. That a is called the constant of variation. That is the non-zero constant that shows your relationship between x and y. All right, so again, that's going to be a couple of important terms that you're going to want to know. Let me get my highlighter out here. So you'll want to know direct variation. Ooh, man, that didn't work out right. Let's try that again. Got to change my opacity. Okay, so you're going to want to know direct variation and you're going to want to know constant of variation. Okay, so moving along, we're going to be looking at how we can write equations with these two different, or x's and y's. Okay, so it says write and graph a direct variation equation that has negative 3, 2 as a solution. So what that means for us is negative 3, 2 is a point on our line. So what we can do is take negative 3, plug it in for x into our equation here. We can take, so negative 3 for x, we can take 2 for y, plug it in here. Since we know that we have a direct variation, we know that the points are going to fit into this line. So then we can solve for a, and that's going to give us the equation of the direct variation line. Okay, so plug in 2 for y, oops, pin, 2 for y equals a times negative 3. And then we just solve for a. So we're going to take negative 3 into both sides. So a equals negative 2/3. Now all we do is take that a and plug it back into our direct variation equation to show the relationship between x and y. So our equation is going to be y equals negative 2/3 x. And the way we graph that would be, to start off with, we would plot the point negative 3, 2. Eek. These lines get really blurry. And then we would just use our slope of negative 2/3, which also is our constant. And we find more points on the line. So we can go up to left 3, 1, 2, 3, and then down to right 3, and we can draw our line. Notice every time if you have a direct variation, your line is going to go through the origin every single time. Sometimes it's going to be a positive slope, or in this case, a negative slope going down from left to right. But it's always going to go through the origin right there. Okay. Now, example 3 is the exact same kind of problem. It's just worded a little bit differently. It says the variables x equals 4 and y equals 8 vary directly. So there's a direct relationship between those two variables. Write an equation that relates x and y. Then, and this is where it's different from the last example, find y when x equals 12. Okay, so it's the same thing the way we started out last time. We know that if these two variables vary directly, then we're going to have y equals a times x. First step we're going to do, just like that last step, is, last example, is we're going to find A. So we're going to plug in 8 from our problem right there for y equals A times x, which is 4. And then we solve for A. So we're going to divide both sides. So A, ooh, that's ugly. A equals 2. Okay, so that means that I can take that value, plug it back in up here, and write my equation y equals A is 2 times x. And that describes the relationship between x and y in this direct variation. All right, now the next part of the equation, though, the question says to find y when x is 12. So now that I have my equation, and I know that for every x value that increases, y value is going to increase 2 times that, I can just plug in that x value, y equals 2 times 12. So when x is 12, y is 24. All right, so 2 answers. Oh, man, circled the wrong one. Okay, so let me box in the right thing here. Here's our direct variation equation, which is just fun to say. And then that's our value of y when x equals 12. Okay, next example is very similar. It says the variables x equals -6 and y equal 8 vary directly. Write an equation that relates x and y, then find x when y equals -4. Same thing as what we did last time. So we're going to plug in our variables into the equation y equals a times x. All right, so I've got 8 equals a times -6. So 8 equals -6a. Didn't have to write out that step. So divide both sides by -6, and a equals -8/6, which I can reduce to 4/3. Okay, so then my equation of direct variation then is y equals -4/3 x. Okay, so that's part 1 to that problem. Part 2 is to find x when y equals -4. So we're going to plug in -4 for y equals -4/3 times x, which is what I don't know. All right, if I want to solve for x, I'm going to multiply both sides by negative the reciprocal, which I almost wrote the wrong thing. Good thing I caught myself. Reciprocal -4/3 is -3/4. So multiply -3/4 on both sides. So then x equals negative times negative is going to give me a positive. And then this 4 and that 4 are going to cancel each other out, which just leaves me with x equals -3. And that is my second answer. So the equation that relates x and y is y equals -4/3 x. And the value of x when y equals -4 is -3. Okay, so these are some problems that we did in class on our whiteboards. There we go. It says the number of pages P a student can read varies directly with the amount of time in minutes spent reading. Okay, so I'm going to immediately stop and set up my equation, because when they vary directly, I know that that's just some number A times one of the variables. So P, the number of students, oops, I mislabeled that. Instead of X, that should be T. times P equals A times T. I know that because they vary directly, so they're going to fit nicely into that equation. The student can read 90 pages in 60 minutes. Write an equation that relates P and T. So all I need to do, exactly like the last couple examples, is plug in my variables, numbers for my variables. So I've got 90 for pages equals A times 60. And this is going to help me find A, which is then going to help me find my relationship and therefore write my equation. So I'm going to divide both sides by 60. So A equals 9 over 6. If I reduce that, it would be 3 over 2. Okay, so then my equation is P equals 3 halves T. All right, then it says, predict the number of pages the student can read if 90 minutes is spent reading. So my T is 90. All right, so 3 halves of 90, that would give me 45, and then 3 times 45 would be 90 plus 45 more. So 135. So you can read 135 pages if you read for 90 minutes. It's really cool to know. You might need to know how long it's going to take you to read. Say you had 70 pages of anatomy and physiology to read. You can set up a time schedule for yourself. Okay, on to the next example. Very similar. The cost C of going to the movies varies directly with the number N of people attending. A group of 4 paid $14 to go to the movies on Friday. Write an equation that relates C and N. How much would it cost for 7 people to go to the movies? Okay, so we know that the cost of them going to the movies is in direct relationship with the number of people. That makes sense because the more people go, the more it's going to cost. It's a direct relationship. Okay, so it says a group of 4 paid $14 to go to the movies. So we can, to find what A is, set it up. 14 equals A times 4. I'm laughing a little bit on the inside because we have done this problem several times. We've just never done it as a direct variation. But if you think about it, it does work as direct variation. Okay, so A equals 14 divided by 4. If I simplify that, would be 7 over 2. Which means it costs $3.50 to go to the movies. All right, so how much would it cost for 7 people to go to the movies? My cost is 7 halves N. So my cost would be 7 over 2 times the number, which is 7. So 7 times 7, if I multiply across, would be 49 over 2. This is a cost, so I have a feeling we probably should write it as a decimal. 49 divided by 2 would be $24.50. I'm thinking, where are those people going to the movies? Because it costs me a lot more than that to go to the movies. Okay, so one more example. This is a problem you might be seeing in physics at some point. According to Hooke's law, the force that is needed to stretch a spring varies directly with the amount that the spring is stretched. So we're going to go ahead and write an equation. That would be force equals whatever your A is times your distance that it's stretched. So example A, it says if 64 pounds of force stretches a string a distance of 8 inches, write an equation that relates F and D. So to find the equation, I have to find what A is to show the relationship between the two. So I'm going to plug in my F and D and solve for A. So that gives me 64 equals A times D, which is 8. Divide both sides by 8. So A equals 8. That's not my answer. My answer is to write the equation. So my equation is, whoops, silly me, thinking it's an equation, so I'm trying to write it as Y, would be force equals 8D. And that would be the equation for that particular spring. Each spring is going to vary a little bit, but that particular spring, that's the relationship. All right, then it says predict the amount of force that is needed to stretch a spring to 14 inches. So it's the same formula. So we got force equals 8 times 14. If I just plug in everything to the equation, I don't have my calculator on me. 8 times 10 is 80. 8 times 4 is 32. So it's 112 is the amount of force that would be needed. May not sound like a big deal to you, but some of the rides that you ride at Six Flags or wherever you may go are springy. I don't know what to say, springy. So might be important to know that the people who built those rides actually understand Hooke's law and the direct relationship, and that way you don't go flying off of the spring whenever it's unloaded. Okay, so the next thing is in our journal, I asked everybody to use complete sentences to answer what is a constant of variation. So using your own words and some of the things that we talked about today, how would you describe the constant of variation? All right, and last but not least, your assignment out of the workbook. I want you to do pages 25 to 26, numbers 1 through 3 all, and then 6 through 20 even. That is all.